Okay, so I want to talk about the calculator, scientific notation in the calculator. So the idea is, you're gonna look at doc, setting status, document settings, and so we're looking at two things: exponential format and calculation mode. It kind of changes on me sometimes. I think I figured this out. Right now, it's in normal and auto. So we go, okay. So I type the number like, I don't know, 60,000. Hit enter. You get 60,000. Now, what we want to do is we want to convert this into scientific notation. We kind of know, well, let's see. So, doc, settings, status, document settings. We're going to change the exponential to scientific, and we're going to change the calculation mode to approximate. Okay, let's try this again. 60,000, enter. It puts in the scientific notation. So standard scientific, and recall from scientific notation, it's 6 times 10 to the fourth. They just put the E in there to save space. Let's try another thing. Let's do the number, 0.000, 387. Delete that. And let's hit enter. It turns it into scientific notation. So we recall, yes, it becomes 3.87 times 10 to the negative 5. And then the example, you can simply use this, you can put numbers in. So for example, how would you like 4,000 times 50,000? Well, maybe you know that it's 10 to times 4 times 10 to the third times 5 times 10 to the fourth. Let's see what happens. 2 times 10 to the 8th. I want you to use the laws of exponents, to figure out why it's not 28 times 10 to the 7th becomes 2 times 10 to the 8th. And then we can use this for division. So for example, the problem that we saw in our class, if you recall the problem, we spoke about the Bangladeshi, and there was 163 million, and that was 1.63 to the 8th, and we divided that by 75,000, which was 7.5 times 10 to the fourth. And the question was, we know that, so let me put this back. Menu, doc, setting status, document settings. Let's put scientific back to normal, approximate back to auto. Okay. So we have, let's see. So we have 163. So the idea is 1.63 divided by 7.5. We end up with 0.21733. And so the idea is if we think about this, it's 0.2137 times 8 minus 4 times 10 to the fourth. But that's not the answer we got. Let's go back to doc, settings, document settings, normal, scientific notation, and I want to put in an approximate. Okay, so let's see what happens when we do 163 million, which is the population of Bangladesh, divided by 75,000. Remember, the problem is we're breaking up this into 75,000 towns. Let's see the answer we get. So I want you to think about, how did we go from 0.217 times 10 to the fourth to 2.17 times 10 to the third? And that's something you're going to explore on your own. But once again, this is how we go from standard to scientific notation, or we can go from scientific notation or back to a decimal form. So let me put doc, settings and status, document settings, scientific. I'm going to put it back to normal, auto. Okay. And so maybe you get the problem, 5 5 times 10 raised to the 7th times, how about 3.8 times 10 to the raised to the how about the negative third? And so this is in scientific notation, but I want this back in regular numbers. The calculator does it for you. We know it's 5 divided by 3.8, and we know it's 10 plus, 5 times 3.8, 7 plus negative 3. Let's see what the calculator, but we want a regular number. We took it out of scientific notation, hit enter, 190,000. And if we want to put 190,000 in scientific notation, we could do, doc, setting status, document settings, scientific, approximate, okay, 1.9 times 10 to the 5th. So this is how you go back and forth. Now, please remember, please note, I talked to your physics and science, your science teachers. They said for IB, for physics and chemistry, there is a part 1 where you don't get to use a calculator, but it's very basic. So you please the calculator. Sounds good. Okay, let's do the next lesson. Division, exponents, and scientific notation. So there's 3 more rules. They all have to do with division. And simply put, the first rule is if you have x to the a divided by x to the b, it's x to the a minus b. Very straightforward. Like with multiplication, you had addition. With division, you have subtraction. And you can test this out. Let's just test this out. So x to the 5th divided by x squared. Let's say you weren't sure. You know, always go old school. X, 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 x. Cross this out. We're left with x to the 3rd, and that verifies the result that x to the 5th divided by x to the 2nd is equal to x to the 5 minus 2, which is x to the 3rd. Okay, and same idea here. Once again, let's say I have a to the 5th times b to the 7th divided by, a to the negative 6 divided by b. Well, first of all, when we're in the world of exponents, we're looking for the same base. So the a's, I'm going to subtract the exponents, and the b's, I'm going to subtract their exponents. So I have a, 5 minus negative 6, and I have b, which is 7 minus 1. Final answer, a to the 11th times b to the 6th. Once go, the rules don't change. It doesn't matter that the exponents are negative or zeros or even fractions. When you divide with the same base, you subtract the exponents. Good. Number 2. Number 2 is kind of interesting. It's kind of like power to a power. No. This one is like power to a product. This is like power to a divisor, the division. So x over y to the a power is simply x to the a over y to the a. And so, for example, I might say, what is 2 to the 3rd to the 5th power? And you would say, okay, well, it's 2 to the 5th over 3 to the 5th. And that's basically it. Well, unless we have a calculator, we're really not interested in figuring this out. It's, once again, we're going to see, because the introduction of scientific notation, we need exponents to represent really, really large numbers, but in a simple way. The last rule, which is kind of cool, is if you have x divided by y and you're raising it to the negative n, the rule is y over x to the n. Now, this is kind of interesting. I think it's kind of interesting. So, for example, if I say, 5 over 6 to the 3rd, right? A negative 3, you simply write it as 6 over 5 to the third. Now, it may seem silly, but the example I like to give is, and let me get a new pen. I'm running out of it. The example I like to give is 1/2 to the negative third power. Well, what do you think about that? 1/2 to a fraction raised to a negative exponent. Well, the rule says if you raise it to a negative, just flip the fraction and change the sign. So this becomes 2 to the third power, or 8. And I like this because this is kind of, let me get a new pen, I'm running out of ink. This is kind of cool because this is what we do in math. We're representing the simple number 8 as a fraction raised to a negative number. It kind of contradicts everything, we thought, not contradict, but it really forces us to expand our thinking, that we now can raise a fraction to a negative exponent and we get the number 8. I think that's kind of interesting. So this is what we're doing. We're just fooling around with these ideas. So follow these rules for the exercises and you'll be in good shape. And you'll notice it's all the same rules and stuff. The rules don't change. Once again, when you're dividing by the same base, you subtract the exponents. When you're raising a quotient to a power, the numerator and the denominator get raised to the same power. And if you're raising this is a little advanced, but if you're raising a quotient to a negative power, it's like raising the reciprocal to the positive. Now, let's talk about scientific notation. I'm just going to put some examples up, and then the next part of the video is going to shift to me with the calculator. If you recall, with scientific notation, right, it's versus, so there's standard notation, and there's scientific notation. Now, over the years, you've been taught to write numbers like standard notation, like 59, like 5,900. Or as you start to learn decimals and fractions, you might learn, 0.0073. Well, this number is 5,900. This number is properly read as 73 10,000ths. Maybe an example was the distance of the Earth from the Moon. I think that's 93 million. 93 million, right? So the question is scientific notation, and you learn that scientific notation was representing a number as a digit times a power of 10. And you learn techniques. You started with decimal, and you moved to the left or the right until you got like a number between 1 and 10. 1, 2, 3. And so it was 5.9 times 10 to the third. Or in this case, when it was a really small number, if you started with 1, 2, 3, this was 7.3 times 10 to the negative 3. And then a final example was, 93 million. You had to know what 93 million is, and you said, oh, you know what, this is 93, 0, 0, 0, 0, 0, 0. And you said 1, 2, 3, 4, 5, 6, 7. And so in scientific notation, it was 9.3 times 10 to the 7th. Now, what I'm going to show you in the video, how to use the GDC to figure this out. In the GDC, the answer you would see is 5.9 E3. In the GDC, you'll see 7.3 E negative 3. And in the GDC, you'll see this answer represented as 9.3 E to the 7th. And so the idea is I want you to explore some of these ideas. For example, so let's do some scientific notation with the division rule. So let's say they're going to say, let's see, they're going to say 50,000 divided by 40,000. So the first thing they're going to ask you to do is write this in scientific notation. So you're going to say, okay, well, it's 5 times 10 to the 4th divided by 4 times 10 to the 3rd. You say, okay, you know what? 5 divided by 4 times 10 to the 4 minus 3. Final answer, 1.25 times 10 to the 1st. That's how we combine scientific notation and division rules of exponents. Now, I have a question for you. Here's my question for you. Let's imagine that, we know that Bangladesh has 163 million people, and let's say that the government has decided that they want to break it up, the whole country, into 75,000 towns. They're starting over in 75,000 towns. My question to you is, how many people would live in each town? So once again, Bangladesh currently has 163 million people, and the government has decided they want to create 75,000 towns. 75,000 towns. How many people are in each village? So how many people would live in each town? Well, the first thing that you would do is write this using scientific notation. So 160 million is equal to 1.63 times, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And 75,000 is 1, 2, 3, 4. Okay. And then we have, let's see, so when we go to our calculator, well, we know the 10 part, that's easy. It's 10 to the 4th. The next thing we would do is 1.63, let's see. Hey Siri, 1.63 divided by 7.5.
1.63 divided by 7.5 is about 0.2173.
The question is that an acceptable answer? And the answer is no, because we know from scientific notation the digit has to be between 0 and 1. Now the technique is they give you a bunch of rules. I'm not going to tell you the rule. What I want you to do is I want you to explore on the GDC, and I want you to think, oh, wait a minute, let me come up with my own rule. So for the actual answer is 2.173 times 10 to the 3rd. I want you to think about why that's the answer. And we'll come back to the G. I want you to think of this on your own and as you solve these problems. So let's see. I think that's it. I will be putting up right after this the GDC portion. Okay.